All right, what up, everybody? Time for lesson 2. Got my summer vibes. Let me start by saying that first video that was too long, and these ones are shorter, so I apologize for that. But I had to get my babbling out of the way. So let's jump in because we don't want another one of those long ones. So lesson 2 here, we're going to split into 2 parts. One, we're going to look at reading histograms, and then in the next video, to keep them short, we'll look at creating histograms. So first here, you can, in Google Classroom, there's a Word doc that has all these same questions. If you want to like print that out, if you have a printer, I don't have a printer, but if you have a printer and you want to print it out, you can take all your notes on here. But this one is entirely based on a picture of a graph. So if we were in class, I would give you a picture of it, a little picture, and you'd cut it out and glue it in your notes. So we have that. But you're gonna, you kind of have to navigate that. So if you can print it, maybe that's your best option. Maybe you can just print it and cut it and glue it into your notebook and take the notes there. Just something to think about. But anyways, let's see here. So lesson 2, we'll call A, reading histograms. So let's do it. So here we go. We got a histogram. A histogram is kind of like a bar graph for numbers. We'll kind of, I'm doing this a little bit weird reading it first, but I like to see what you guys can figure out on your own if we were in class. So we'll break down the histogram more, but a histogram is like essentially a bar graph for numbers. So here's our context. Statisticians collected a random sample of college freshmen and asked them, how much credit card debt do you currently have? So the histogram here is showing us how many college freshmen, that's what our frequency refers to, fall into different ranges of credit card debt. And so before we even jump into the specific questions, maybe just kind of think about, take a minute, look at this, maybe jot down some notes, whatever, maybe just think about them. But what does this graph tell you? When you look at this, what does this tell you about the amounts of credit card debt for some sample of college students? So jump in, practice reading the histogram here. So first question we got, what's the X scale, right? We always got to pay attention to the scaling when we're looking at a graph. We want to make sure we don't make the mistake of not doing that. Whoopsie. So how wide are these bins? So we call the bars in a histogram a bin. Don't say 100, all right? So we got this right in here, right? So this would be 150, 200. This is our 250. All right, so it seems simple, but that's something we got to pay attention to. So the X scale, and I'm going to use this language because this is what we're going to see when we start to play with this on our graphing calculator. The X scale here is 50. So when we set up the window, the X scale is how wide the bins are, or in other words, what we're counting by. For the record, if we were making this in our calculator, this 100 right here, that would be our X min, and this over here, 650, right? This would be our X max, and then our Y min would be 0, our Y max would be 25, and our Y scale here would be 5. So when we start to create these with our graphing calculator, we're going to have to set up that window and enter those things. So that's why I'm using that language. When we look at a histogram shows us the distribution of one variable. So the frequency on the left side, and I should have said, right, hopefully you pause this and try these on your own, but the frequency on the left side, right, frequency, that is not a variable. That's not a thing we're measuring. The frequency is just, as it mentioned in the context, the number of college students that fell within each interval, from $100 to $150 a debt, $150 to $200, and so on and so forth. So this is not something we measured. The only thing that we measured, the only quantitative variable, so histogram really for quantitative data, right, is the amount of credit card debt, and the unit there would be in dollars. So number 2 here, right, the variable is the amount of credit card debt, and the units would be in dollars, right? And this is a quantitative variable. And so now I just want to get into practicing reading a histogram a little bit, right? We got to know how to read these things. When we get into the class a little more, one of the first couple weeks, whatever, soon we'll start to talk about the shape. We'll talk about, hey, this looks like it's a little bit skewed right. It's unimodal. And we'll start to write about it. We're going to start to write about the center, the spread, the shape, any unusual features, right? So describe this distribution, this yellow graph right here, and write some sentences about it. That'll be one of the first challenging questions, challenging free response that we'll work on. But don't worry, it's my job to teach us, help us practice how to write. Anyways, back to the basics here. How many students have between $250 and $300 in debt? So we're looking at this bin right here. And so how many students were in this bin? We want to look at the height over here, and we're probably thinking something like, you know, that's obviously a terrible line, but it can't be 12.5 right in the middle, so I would probably call this 13. So about 13 students had $250 to $300 of credit card debt. All right, so far no big deal. Let's keep moving here. One thing that's not on the sheet if you use the Word document, but you're right, you could add this pretty easily, just circle this. So what I've done is I have written down what I would say are the heights of all the bins. Now, like if you called this 13 here or 12, like whatever, I'm not stressing about it too much, but of course these three, right, all have to have the same height, the same frequency. And so I've just jotted down, right, the heights of each. And so the first question, not the first one I'm talking about, this is the fourth question, but the question we're answering here is, what does this 21 mean? And I believe there's a question in your summer assignment that asks the same kind of thing. In stats, and so I'm doing this here just to kind of start us writing a little bit, but in stats, everything we write is in context. And so if you write something like 21 data values are between 300 and 350, that's like pretty good, like I guess, because you know how to read the graph, but that's going to be worth 0 points. In stats, free response are graded as essentially, partially, or incorrect, so it's not really a point system, which is weird, and we'll worry about all that throughout the year. But this, right, there's no way this is essentially correct because everything we write in stats has to be in context. One little side note, when I say between 300 and 350, and again, this is coming up in more depth in the next video, but if we have a value that falls right here, so like 350, if a student had $350 of credit card debt, they would fall in the bin to the right. So if a data value falls on the end of an interval, it always goes in the bin to the right. So there's no 200s in here. Any 200s would be in this bin to the right. But anyways, back to the question at hand. This in pink, decent, but not essentially correct, not good enough for us in our class because it's not in context. So we want to talk about context. So this 21 over here tells us that 21 students, but let's even be more specific, 21 college students had $300 to $350. And we don't even want to just say of debt, like what, like car debt? I don't know. But let's be specific, of credit card debt. Now in pink, right, this person has the right idea, not written well enough for AP stats. Green, context, that's what we want. And so that's what that 21 means there. I'm not even gonna, oh my God, what's happening? Just pretend none of that ever happened. So that's that. All right, what do we got next? Okay, how many total students were surveyed? Now, of course, right, hopefully we know, hopefully don't have to tell you this. Pause it, try this on your own. But I will say down here, so this sample size, that's another vocab word. We use the letter N to denote the sample size. So if number 4 just said find N, it would mean the same exact question. What's the total sample size? So think about that, right? We know 21 students had $300 to $350 of credit card debt. We know 13 students had $350 to $400, 13 students had $400 to $450, 2 students had $600 to $650 of credit card debt. So think about, how could you find the total sample size? How many total college students did we survey? And hopefully, right, pause it, we realize what we're gonna have to do here, oh no, I did that crazy thing again, is add each of these frequencies, right? We got 23 students in that first bin, 25 in the next, 21, 13, 21, 13, 13, 8, 4, 1, 2, right? And we want to add all this stuff. Now, I should never see you doing this by hand, right? We have to like get these calculators for this class. We need a graphing calculator. They're like pretty expensive, so might as well use it. Well, let's see here, 23, 48, 69, 79, 82, 102, 103, 116, 129, 137, 141, 142, 144. So it looks like we have about 144 students in this survey. And I'm just going to like hope that I did that correctly. All right. If not, this whole video is wrong, and that's embarrassing because anyone on the internet can see it. So, you know, hopefully I can add. All right. Next up, number 5. This, by the way, is a common question. So find sample size. We add, maybe you want to give yourself some notes, right? Add all the frequencies or the heights, maybe you call them, whatever. So anyways, what's up? Number 5. What proportion of students have between $404 and $500 of credit card debt? So when we see this, right, we want percentage. I know I cut one of these out on the worksheet, but I can't remember which one, so I guess I have to do both. So $400 to $500 in orange, we're looking here. So for number 5, we've got a total of 21 students, right? 13 plus 8, 21 students out of 144 had $500 of credit card debt. And when I do 21 divided by 144 on my calculator, I get 0.145. 146 if I know how to round, which is about 14.6%. And then similarly, right, no big deal, I don't really need both of these questions, but I can't remember which one I cut off. So in blue, what percent of students had less than $200 of credit card debt? Now we're looking over here in these blue bins to the left of the 200. So 23 and 25 together, that gives us 48 out of 144 students, which I'm pretty sure is 33.3%, but just, yeah, double checked it. So 0.333 repeating, or about 33.3%, right? So no big deal, right? Just some basic reading of histograms. And you'll see, again, some of this in your summer assignment. Next up, almost there. I think we just got 7 and 8, and then that's it. All right, now we get to the tough ones, maybe. So the approximate range for credit card amounts. So the first thing we have to think about here is when we look at a histogram, and this is getting into some of the knowledge of how to make it. So in some ways, this might make more sense after you watch 2B. We know, for instance, there are 2 students who have between $600 and $650 of credit card debt. However, we have no idea what exact amount of debt those 2 students had. So these 2 students could both be 649. They could be, right, 601 and 630, like whatever. They can't be 650 because remember, if there's a 650, that goes in the bin to the right. But they could be 600, right? So both of these 2 students, right, these could be a number as low as $600 of debt, or they could be as high as 649. They can't be 650, right, because that would go in the bin to the right. Again, any number that falls right at the end of an interval always goes in the bin to the right, so that's important. On the lower end of the spectrum, these 23 values, same thing. We know there's 23 data values that fall between $100 and $150, right? There's 23 students that have $100 and $150 of debt, but we have no idea what each of those 23 data values, each of those 23 debt amounts were, right? All 23 of them could be 100. Right? They could, all 23 could be exactly $100. Or all 23 could be not 150, because if it was 150, it would go in the bin to the right, right? It could be 149. Now I really made a mistake. This could really be $149.99, and same thing over here. This could be $649.99. So when we're looking at the range, so the range is the maximum minus the minimum. But we can't give one exact answer for the range from a histogram because we cannot figure out the exact maximum because we don't know what these 2 data values were. And we cannot figure out the exact minimum because we don't know the exact values of these 23 data values. Now, if we had the actual data set, range is super easy. Just take the biggest number minus the smaller number, cake, right? No big deal. But here for our range, we have to think about an interval. So the range is going to have to be between 2 numbers. It's going to have to be at least something, but at most something else. The widest possible range we could have would be if the maximum were 649.99 and the minimum were 100. So the widest possible range we could have, right, is from here to here. And so in pink there, that's 649.99 minus 100 gives us 549.99. So the biggest possible range is $549.99. And if you said roughly 550, that would be fine, right? The biggest possible range is 650 minus 100 roughly, right? It can't actually be 650 we talked about, but whatever, that's what this roughly is. So the biggest possible range in pink, the widest possible range is 650. But that doesn't have to be the range because we don't know those exact data values. So we also have to consider the smallest possible range. The smallest possible range we'll go in blue here would be from this 149.99 or this roughly 150 over to this 600. And so if we do 600, right, that's the smallest thing these two data values could be, minus 149.99 or roughly 150, that's the biggest these could be. The blue here, right, gives us the narrowest possible range, which is going to be, oh man, 450 bucks about. So if you said roughly 450, that's fine. If we subtract with the 99, we get 450.01. So for the range with the histogram, right, we can estimate it. We can suggest it's the biggest possible range and the smallest possible range, right? Biggest possible range in pink, the kind of the outsides of the two bins on the ends. The smallest possible range, kind of the inside of the two bins at the ends, but we cannot give the exact range, right? And it could be significant, right? There's a big, I don't want to say range, but there's a variety of possibilities here, right? The range could be $450, could be up to $550 about. So that's one thing we have to consider with the range. If we have the raw data, range is much easier. This is tricky, right? This is why office hours are here. So if you're watching the show, you have no idea what's going on, right? Send me some remind messages, come see office hours, and we'll talk more. The median. So the median, again, we cannot give the exact median because we don't have the exact data values. So as we think about the median, I'm pretty sure we all know the median is the middle data value, the middle amount of credit card debt, the middle number. Now, if we were going to list all of the data values in order, from our previous answer, we know there are 144 data values, right? So if we were going to start to list each number in order, there'd be 144, right, numbers to fill in. Now, we cannot do that because, like, I don't know what the first 23 data values are. I know these first 23 data values are between $100 and $150. But I can't determine their exact value just from a histogram. So there's no way we can get the exact median because we cannot reproduce the actual exact original data set from this graph. But what we can think about is this middle number. The middle, right, we got to cut this list in half. So if we do that, if we had 144 numbers and cut that in half, that tells us that the median is going to be around the 72nd data value. Now, the median actually isn't going to be the 72nd data value. It's going to be between the 72nd and 73rd. So to think about that, let's pretend n were 4. If you had 4 dots, right, and you do 4 divided by 2, you get 2. But the second dot, that's not in the middle. The middle, what did I just do? The middle would be right here. Right? That's how we would split this yellow data set in half. So the middle would be between the second and the third data values. So anytime the sample size is even, we're going to run into that same problem. You could memorize that rule, but that's not really my style. I'm about understanding. You could easily make up an example like this. You could realize, oh, if I have an even, when I do n divided by 2, it's not really the second, it's between the second and the next one. So based on that logic, the median's actually the middle of the 72nd and the 73rd data values. Another way to approach this, some people for median just kind of use the formula n plus 1 over 2. which would give me 145 over 2, right? 144 plus 1, which gives me 72.5, which connects to this idea, right, that the median's between the 72nd and 73rd data value. So whatever way works for you, right? If you watch the Stats Guy video, I think, about the median, I think he uses this, I can't remember actually, but whatever. I know if you Google it, right, you're going to see some methods with the n plus 1 over 2. If you're a formula person, sure, right? Either way, kind of that's the logic. We're trying to figure out where the middle value would be, and it'd be between the 72nd and 73rd. So that's the first step. Now, the next step is to figure out what amount of credit card debt, right, would be around the 72nd data value. Well, so now I want to start working left to right. So from here to here, right, that's 23 data values. That's our first 23. So if we listed these data values in order, the first 23 of them would all be numbers from 100 to a 150, right, not including 150. From here to here, this would be the first 48 data values, right? 23 in here and then another 25 in here. So if I listed all those values in order, right, the first 48 data values would be between 100 and 200. And then from here to here, right, now we're up to our first 69 data values. We need to find the 72nd and 73rd. We're not quite there. Now if we add this 13, that takes us up to 82. And so the 72nd and 73rd data values have to be somewhere in this bin. Right? Up to here was the first 69 data values. Up to here was the first 82 data values. And so, right, to get from the 69th to the 82nd, that means we went past the 72nd and 73rd. So the median has to be in this bin. Now, don't tell me the median's 13 because we're talking about a median amount of credit card debt and there were no credit card debts of 13. So the median is the amount of credit card debt, right, which is between $250 and $300. So I would challenge you, if you really want to, right, develop your understanding, sure, you can watch another video about this. Another thing you might do is try to go back and kind of recap this in steps, right? How do you find the median for any histogram? To wrap it up, and you can, right, you can end this right now. This is the last question. But another thing, maybe this helps, what I've seen some students do, right, is so they get that, right, kind of back to the 144, we divide by 2, right? So the median's between the 72nd, but since it's even, it's between the 72nd and 73rd, right? Or we do the n plus 1 over 2 thing, right? To get this, what some students do, between the 72nd and the 73rd, right? That would be the 72.5. And I actually learned this last year. So, right, you guys are going to teach me new stuff. Someone showed me this last year. One student started left to right and subtracted the frequency. So she would do minus 23, right? And that would give 49.5. And then she would do minus 25. And that would give 24.5. And then she would do minus 21. And that would give 3.5. And then she would do minus 13. And that's going to give a negative number. And she then, so her method, instead of kind of adding up to how do we get to the 72nd, 73rd, which is what I just did, she would subtract, and then she knew once she got whatever bin gave her a negative, that's when she found the median. So when we subtracted this 13, it took us into a negative, which means the median's in this bin, so the median's between 250 and 300. And I like to share that because that's literally something that a student in the classroom showed me last year that I had never thought about. So I'm excited to see what you guys might teach me this year. All right, so that's how we're going to find the median from a histogram. I can picture that as a multiple choice in your summer assignment. But for now, that's it. So next up, we'll take a look at how to create a histogram. Until then, have a good day, everybody.